Okay. If you have any question, feel free to raise your hand there and let me know. Okay, for this session, we are going to cover the topic of interest, which is the Buckingham Pi-Theorem. Okay, so have you tried to search anywhere, or have you ever heard about the term Buckingham Pi-Theorem? Anyone? Or have you studied before the Buckingham Pi-Theorem? Or this is the first time you hear the theorem, Buckingham Pi-Theorem?
Saya pernah dengar.
Dengar
I've
kat mana
heard it
tu?
before. This is my second time taking fluid class.
Oh, I see.
Ah,
Okay, for the Buckingham Pi-Theorem, let me explain to you in a simple way, okay? Let me share you the screen. Okay, by the way, thank you for responding, okay? Because I want to know your feedback. Okay, so this is the slide of Buckingham Pi-Theorem. Okay, basically, the rule of the intentions of Buckingham Pi-Theorem to achieve the similarity. So how to achieve the similarity? We are going to use the Buckingham Pi-Theorem. So let pi, okay, this is the symbol of pi, pi, represent a non-dimensional parameter. Okay, so what is non-dimensional parameter? Anyone knows what is a non-dimensional parameter? Anyone would like to try? What is a non-dimensional parameter? Non-dimensional. Okay.
Strain.
What do you mean? Strain.
Strain. S-T-R-A-I-N. Stress and strain.
Do you mean the spring? S-P-R-I-N-G?
Strain, doctor. S-T-R-A-I-N.
S-T-R-A-I-N. Strain.
Yes, doctor.
Okay, what is strain?
Extension over original length in solids.
Reynolds
Okay.
number.
Okay. Someone said, Nur Shahira said Reynolds number. Okay, anyone? Parameter can be any kind of parameter like density, viscosity,
Specific gravity.
Specific gravity,
Length.
length. Okay. Non-dimensional is this. Okay, non-dimensional is length only. This strain, do you have the unit for strain?
No units for strain.
No unit, right? No unit. Do we have unit for Reynolds number? And Shahira? Reynolds number, do we have the unit? Reynolds number is?
No.
No unit.
Dimensions.
So it is dimensional, no unit. Specific gravity have unit?
No.
Okay, no unit. Is the length have unit?
Yes, meter.
Yes, meter. So only length is the non-dimensional. Okay, all these strain, Reynolds number, specific gravity or specific heat capacity, all this is a unitless, right? So non-dimensional is a unitless, don't have any unit. Everything have sorry, wait, yeah.
Doctor, you mean equal to 0?
Okay, wait. So non-dimensional sorry, non-dimensional have a unit. Okay, have a unit. Okay, non-dimensional don't have any unit. Okay, so non-dimensional. Okay, so let's say this one non-dimensional is referred to having a unit. Okay, dimensional parameter unitless. Okay, for example, like Reynolds number, specific gravity, strain. Okay, for the nine-dimensional, it can be the velocity. Velocity is meter per second. It can be the length. It can be dynamic viscosity. It can be density. Okay, so that is what we call a non-dimensional parameter. So in general, there will be one pi that we call as a dependent pi. Okay, so dependent pi we denote as pi1. Pi1 is a function of several other pi's, which we call them as the independent pi. Okay, it's okay, I will explain to you later on. Okay, for example, like this. We have, remember, for example, y equal to mx plus c. Okay, y represent here is a dependent variable. Okay, this is a dependent variable. Okay, here is, for example, x is independent variable. Okay, so for this case, this is just example. Okay, so what the pi means here is pi1 will be the dependent variable with the functions of pi2, pi3, pi4, so on until pi k. Okay, so this pi1 represent the dependent variable. Pi2, pi3 and so on here represent the independent variable. I believe you understand, yeah, what is dependent and independent variable. Okay, until pi k, where k is actually number of pi. Okay, for example, we have 100 of pi, so k is 100. So that is the value of k. So in the experiment in which a scale model is used to simulate the prototype flow. So that means we have the model and we have the predicted prototype. So how do we predict the prototype flow? Based on the model. So each independent pi of the model must be identical to the corresponding independent pi of the prototype. Okay, so this is how we predict from the model to the prototype. So for example, okay, like pi 2m, okay, this is an independent variable. Independent means this term. Pi2 start with pi2, pi3 and pi4 and so on. So pi2 of the independent, this is for model, should be equal with the pi2 of the prototype. Or pi3 of the model should be equal to the pi3 of the prototype. Okay, this is how we used to predict from the model to the prototype. Okay, so far do you have any question pertaining to the pi?
No, doctor.
Okay,
This
thank
is
you.
okay.
Okay, thank you. So if we have this, the dependent pi of the model is guaranteed to equal to the dependence of the prototype. So if we have this, that means the pi 1 of the model should be equal to the pi 1 of the prototype. Okay, simply like this. Okay, how do we generate the pi? So as you can see, we have so many number of pi. Pi 1, pi 2, pi 3, pi 4. How to generate those pi's? Okay, that is why we're going to use the Buckingham Pi-Theorem. Okay, Buckingham Pi-Theorem. Okay, so simply the Buckingham Pi-Theorem is used to generate pi. Pi 1, pi 2, pi 3. Okay, so it is a simple way to explain Buckingham Pi-Theorem is used to generate pi 1. Pi 1 is what? Pi 1 is dependent variable. Pi 2 and so on is the independent variable. Okay, so when the Buckingham Pi theorem can generate those pi, we can form, okay, we can actually form like this. Pi 1 is the function of pi 2, pi 3. Okay, this is what we want to get the final output of this course. Okay, this is just a simple like y equal to mx plus c. Okay, so this is y, so this is x. Maybe this is x1, this is x2. So how to make it simplify? That is why we make it generalized. The pi 1 is a dependent variable that depends on pi 2. Pi 1 depends on pi 3. Pi 2 don't depend any of terms. Okay, same goes to pi 3. Only pi 1 depend on 2 and 3 pi. That is why we call pi 1 as a dependent variable. Pi 2 and pi 3 as independent variable. Okay, so to cover the theorem, let's take a look of the example of the falling ball. Okay, for example, we have the ground. This is the ground. Okay, and then we have the ball. Okay, this is our ball. Okay, and then the ball, okay, have the initial velocity. Let's say the initial velocity W naught is the initial velocity. Okay, W can be the velocity. Remember, we have U, V, and W. This is in terms of what type of direction? Here, U is a velocity, V is a velocity, and W is the velocity. What are those different here? Okay, U is the velocity for what? Anyone? U is the velocity for what? And V velocity for what? And W is the velocity for what? What is the specific things about U, V, and W?
Dr. U is the velocity in the x direction. V is in the y and W in the z direction.
Yes, perfect. So U is the velocity in the x direction, V is the velocity in the y direction, and W is the velocity in z direction. So in here, okay, let's say this is our coordinate, okay. This is the, okay, this is the z naught. Sorry, z naught is actually the initial elevation. Okay, the initial elevations of this ball. And this is our reference frame. Our reference frame is here, the Z. And this is maybe the X. And maybe this is Y. Okay, so this is our reference frame. All right, so from here we have the initial speed, and then we have some more, we have the gravity. All right, so from here, okay, the Z, let me draw like this. This is not proper, should be straight. Okay, so basically we want to know we will return to the example of the falling ball. Okay, this ball is falling. Okay, we want to know what is the height in terms of Z. So here we can say the Z is the function of, okay, is the function of initial speed, initial velocity, is the function of gravity, is the function of initial elevation, as well as the function of time. Okay, so far you guys understand? Okay, for this case we want to see what is the height. Okay, what is the dependent, the dependent, the changing. What is the height when there is a variable? Okay, we have the independent variable, initial velocity. If we change the initial velocity, will the height will change? Anyone? If we do change the initial velocity, what will be the elevation? Is it changing or constant? It will change, right? Okay, so that is why Z is what we call as a dependent on the W. The Z is a dependent variable on G, and as well as Z0 and T. Okay, that is why we need to study what will be the effect of height elevation with respect to the W0, G, Z0 and T. Okay, so this is our case study. So how to perform the pi? So we need to form the pi. Pi1 is the function of pi2, pi3, pi4 and so on. So from here, I need you to focus on 6 steps to this theorem. Alright, there are 6 steps to generate the number of pi's. Remember, pi1 for dependent variable, pi2, pi3 and so on is independent variable. So our objective now, I want to generate this. Pi1 is the function of pi2, pi3 and so on, the number of pi. Okay, so how do I generate this pi? By using the Buckingham, okay, BUCK, Buckingham Pi-Theorem. Okay, so we have 6 steps to this theorem. First, list out all the parameter. So what the parameter that we have? Okay, Z. This is the function. Okay, we want to know the height of the ball with the functions of Z, sorry, with the function of W, initial speed or initial velocity of the ball, the gravity attraction, the initial elevation of the ball, as well as the time. Okay, changing the time will affect the elevation. So how many parameter that we have, including the dependent and independent variable?
5.
5. So we have 5. N equal to 1, 1, 2, 3, 4, and 5. So 5. Okay, just that's it, simple. N should be include dependent and independent. Okay, independent variable. So after we have list out all the influencing factor, the function of this, okay, we need to list the primary dimension of each of the n parameter. So we have z. Okay, z is the parameter number 1. Okay, z. And then we have w. And then we have gravity. And then we have z naught. And this is the time. Okay, with respect to this, okay, let me make a, okay. With respect to this, we want to express in terms of dimension. What is the dimension of z? The dimension of z is
Meter?
L.
a meter. So meter is L.
Oh, L.
Meter is the unit. Dimension is after we get the unit, we know the dimension. Okay, we have the dimension. Remember, dimension only 3, M, L, T. M is mass, L is length, or in meter, T is time, not temperature. Yeah, temperature is this. But this is our basic thing, 3 things. Okay. So W is W naught is the initial speed. What is the dimension of initial speed?
L over T?
Yes, perfect. So L1 T negative 1. Okay, this is like this. Okay, gravity. What is the dimension of gravity?
L over T squared.
Okay, L over T negative 2. Okay, we can put this way. Okay, what is the dimension of Z? The same with L. What is the dimension of time? Which is capital T. Okay, so after we have list out all the respective of the dimension, Z refer to L, G refer to L1, L the power of 1, T negative 2. Okay, I think let me explain it. Gravity. Gravity is the gravitational acceleration. Okay, gravity is the same unit with acceleration. So what is the unit of acceleration? Meter per second squared. So the unit of meter refer to the dimension of length. The S is the time, refer to T. So that is why L T negative 2. Can you see here? L T negative 2. This is just a revise here. Okay. Now, step number 3, guess the reduction J. Okay, as the first guess, set the J equal to the number of primary dimension MLT in the problem. The expected number of pi, we call as a K, is the equal to n minus J according to the Pi-Theorem. Alright, so how to guess, how to know the number of J? J is directly referred to MLT system. Okay, so J, I think the small j. Okay, j. Do we have the m here, everyone? The dimension of m? No, right? We don't have m. Do we have L? Yes, we have L. Do we have T? Yes. So, basically our j is 2. Okay, so our k, in order to know the number of pi term, as I mentioned before, you can see the k here. I want to know how many number of pi. Okay, until k, the final one. So k is the formula simply n minus j. So n is the total. Okay, total list of total parameter. We have 5. 5 minus j, which is 2, equal to 3. That means we have pi 1, pi 2, and pi 3. Okay. So far, you guys understand? Okay. it is just like this. Pi1 is the function of pi2 and pi3. This is what we want to achieve at the end of the this part. Okay, so choose step number 4. Choose J scaling parameter, or sometimes in other book we call as the M repeating variable. Okay, that will be used to construct each pi. Choose wisely. Okay, how to choose? Okay, first we have 3 rules. The first, how to choose the J scaling parameter, the variable that will be combined with each remaining parameter. Okay. Yeah. Okay, first it should be, okay, the J scaling must be from the independent, must be choose from the independent variable. Secondly, must include all basic dimension. I mean the basic of dimension M, L, and T. And finally, must not form the pi term by themselves. Cannot form the pi term by themselves. Okay. Alright. So for now, the J I should choose from this parameter. Alright, you can see we have J, we have 2. So that means we have to select 2 parameter from the independent variable. Can you see here? Okay, I have J equal to 2. I have to select J from the independent variable. Which one from the independent variable? This one. This is independent variable and this is dependent variable. Remember that the J cannot be selected from dependent variable. Okay, I need to select 2 only. So now we have 4. How do we select? How do we choose? Okay, this is the rule. Must include all the basic dimension. For example, I want to select W naught. Okay. And then I want to select the Z naught. Okay. Why? You can see if I select W naught, I have L and T. Okay. As well as I select the Z naught, I have the L. So I have all the basic dimension. Remember our basic dimension is M, L, T. So I have L, I have T, as well as L. Okay. You also can select the gravity. It's okay, no problem. If you select gravity, it should be any mistake. Okay. So my case, I try to select W and Z naught. Okay. You can as well select W naught with T. Okay, it's okay, but you must select only 2. So if you select Z naught, for example, if you select okay, can you see Z naught and Z with Z have the same dimension, so you cannot select lah the same dimension. Okay, so you cannot select Z with Z1, Z with Z naught. Alright, so first I select W naught with Z naught as my J scaling parameter. Okay, so my J scaling parameter, or sometimes in other book we call as a M repeating variable. Okay. Okay. I select to be W naught and the Z0. Okay, you must select only 2. Okay, so from here, I need to generate the pi term. The pi s means we have so many number of pi 1, 2, and 3. At a time, by grouping the J scaling parameter with one of the remaining parameter, forcing the product to be dimensionless. Means here, forcing the product means it is unitless, don't have any unit. Alright, so construct all the k pi's term this way. Remember, the pi 1 is the dependent variable. So from here, I want to construct pi 1 is like this. It's a function of pi 2 and pi 3. Because we have k equal to 3 only. So start with pi 1. Okay. Pi 1. Pi 1 is the dependent variable. So from here, where is our dependent variable? It is z, right? Our z is a dependent variable. So we should put z here. Okay, because z should tally with the dependent variable of pi 1. Okay, so the rest is actually the J scaling parameter, or sometimes we call as a repeating variable. So because we need to repeat those variable into the pi 1, pi 2, and pi 3. Okay, so this one, W0 and Z0 need to be repeat in pi 1, pi 2, pi 3. That is why we select W0 and Z0 need to repeat themselves at pi 1, pi 2, and pi 3. So I repeat here at W0 and Z0. Okay. So here when I repeat, I should make here as the A1 and here as the B1. I should make the power of A and this is the power of B. Where A and B are constant exponent that we have to find. Remember that the A and B are the constant exponent that we need to find. Okay, so from here we set the Z1. Okay, Z. Okay, here Z W not A1 Z not B1. Okay, what is the dimension of Z? Of course, it is L. Okay, what is the dimension of W0? The velocity.
L over T.
L over T. So we write LT negative 1. So we write this way. L the power of 1. This is also the power of 1. T negative 1. Bracket, we have A1. Okay. And Z1 is L. The power of B1. Okay. So from here, okay, we need to set the L and T equal to the power of 0 and 0. Okay, because we need to make sure, you can see, we need to force the product to be dimensionless. That is why it is equal to 0 and 0. The power of 0 and 0. This is dimensionless. So start with length. Okay, or we can start with time. Okay, time equal to 0. Sorry, the time equal to 0. Okay, so T negative A1. Okay, we don't have any T, right? Okay, so in here we can simply say that A1 is equal to 0. Okay, because this is, we compare 0 equal to negative A1. So we look at the length LENGTH, which is L. Okay, L here, L1. We have L1, the power of A1, L A1. We have L B1. Okay, this is the equal to 0. So how to solve this? This is 1 plus A1 plus B1 equal to 0. We know that A1 equal to 0, cancel. And finally, we can get the B1 equal to negative 1. Okay, from here, pi 1 is equal to Z, W naught. A is referred to 0. And Z naught refer to B, the power of B, which is negative 1. So W naught, okay, W naught, the power of 0 is anything the power of 0 equal to 1. Okay. So we can simplify Z over Z naught. Okay, anyone? So far, do you understand until this one? Anyone, you have any question?
No, doctor.
Okay, thank you. So, let's proceed on pi 2. Okay. Remember that this is for dependent variable. Okay. Pi 2 for independent variable. Okay. We have solved this one, Z. Okay, we have solved. Let's delete the one. Let's delete this one. And we have G and T. Okay. So let's say I try to choose T. You can choose G first. It's okay. I want to choose T. Okay, I select T. If I select T, I delete T. Okay. So pi 2 equal to T. And remember that we need to put the repeating variable or J scaling. Okay, remember that the J scaling W naught and Z naught is a repeating variable. That is repeat themselves in pi 1, pi 2 and pi 3. So it will repeat like this. So repeat lah. W naught A1, Z naught B1. This is a repeating variable, repeating themselves in all the pi. So again, the same thing. So TW naught A1, Z naught B1. Okay, T. The dimension of T is time, which is
T.
T. Yes, T the power of 1. Okay, this one, the initial velocity the same like this one. L1 T negative 1. The same like this one. And then the power of A1. The Z naught is L1, the power of B1. Okay, so let's say this one we need to force the product to be dimensionless. So L0, P0. If we have the mass, we can put the mass equal to mass the power of 0 as well. Okay, so start with the time. Okay, the time T naught, T the power of 0. So you can see here T1, T negative A1. This one, yeah, I try to solve this one and no more. Okay, so from here, 1 minus A1 equal to 0. Okay, sorry. Okay. Okay. So if this is 1, let's say this is 2, let's put here as a 2. Okay. So A2. Thus, we know that the A2 here is equal to 1. Alright. And next we start with the time length, length. So L the power of 0. So L here is L A2. Here L B2. So from here A2 plus B2 equal to 0. So substitute this term into this. So we know already that B2 is equal to -1. Okay, so what we need to do? Arrange them. Substitute in the equation. So pi2, this one, pi2 equal to T W naught. A2 is 1. Z naught B is -1. So rearrange, we will got T W naught over Z naught. Okay, that is the pi number 2. And finally, pi number 3. Let's continue here. Okay, pi number 3. Pi 3. Okay, after we select the T here, remember the pi 1 we select Z, pi 2 we select T, and finally the final we select G. Okay, so from here pi 3 is actually the G here, the G, and continue with a repeating variable. Okay, 3 and this one as a T, right? Okay, sorry, Z naught. Okay, repeat 3. Okay, so GW naught A3, Z naught B3, okay, is actually follow like this, the same thing. Okay, what is the dimension of gravity? Gravity is acceleration, so length T -2. Okay, this is the dimension of gravity. Remember gravity, the unit of gravity is meter second -2. Okay, and then the dimension of W naught, which is here, L1 T -1, the power of A3, and the dimension of Z naught, which is B3. Okay, and then this is all equal to L the power of 0, T the power of 0. And then let's compare with the time. Okay, T the power of 0 equal to, okay, let's look at here, T -2 and T A3, nothing. Okay, so rearrange this one, we will got -2 A3 equal to 0. So A3 is finally equal to -2. And continue for the length. L naught. Okay, length L1. This one L A the power of 3. Okay, this one supposedly L. Okay. So L the power of B3. So let's compare Y plus A3 plus B3 equal to 0. So substitute this one, A3 equal to -2 into here. So 1 minus 2 plus B3 equal to 0. So -1 plus B3 equal to 0. So B3 equal to 1. Thus, our pi here, pi 3 is equal to gravity W naught A3, which is A3 is -2. Okay, and Z naught is B3, which is the power of 1. So rearrange lah. Pi 3 equal to G Z naught over W naught squared. Therefore, we have finally solved pi 1, pi 2, and pi 3. What next? Next, form like this. Pi 1 is the function of pi 2 and pi 3. So pi 1. What is the pi 1? Pi 1 is here. This is our pi 1. So Z over Z naught equal to the function of pi 2, which is T W naught over Z naught. And pi 3 is G Z naught over W naught squared. Therefore, that is the final answer. Okay, anyone, do you have any question? Pertaining
No, Doctor.
Okay. Okay, this is the step lah. Step number 1, list all the dependent or independent variable. Okay, like this. After we list out, we need to list the dimension of all the variable. And number 3, we need to guess the reduction J. J is equal to refer to MLT system. So we have L, we have T, so 2. So the number of pi term n minus J. So 5 minus 2, 5 is n. J is 2, K. So here our K is equal to 3. So we have 3 number of pi. And number 4, we need to choose the repeating variable of J scaling parameter. So how many we need to choose? We need to choose 2 only. Okay, because of J equal to 2. So I choose the W naught. Okay, remember that the J must be chosen from the independent variable. So W and Z. You can also select W and G. You can also select Z with T. It's okay. You will get the same answer. Believe me. Okay. There are many methods. So how to select the J scaling? It must be selected from the independent variable. Must include all the basic dimension. If you go further for another example, you will find this, the second part. Must include all the dimension. Okay. Remember that it cannot be formed by themselves. For example, like the angle. An angle cannot be the repeating variable because the angle is dimensionless. No unit for the angle. Sorry, it is not no unit for angle. It is no dimension for the angle. Okay. So number 5, we generate the pi term with combination of the scaling variable, the repeating variable with dependent variable, the second one with independent variable, and so on. And finally, we form the pi group. Okay, this we call as a pi group. Pi 1 equal to the function of pi 2 and pi 3. So just replace this one. And final step, check all the pi terms are dimensionless. Okay, so that means all this pi term, no unit. You see here, you need to check. The z divided with z, it is unitless. The time, for example, this one, yeah. This is z. Okay, meter over meter, which is 1, unitless. The time, which is second, multiply with velocity, which is meter second negative 1 over z naught. Z naught is meter, so meter can cancel with meter. S cancel with this, so it is 1. So gravity is meter second negative 2 multiply with z naught, which is meter, over velocity squared. So velocity meter second negative 1 squared. Okay, continue, meter second negative 2 meter over meter squared second negative 2. So you can see meter cancel with meter squared. Second cancel with second, it is 1. Now, can you see it is dimensionless, unitless? Okay, so far you guys understand? Until step number 6. Okay, I think that's enough for today, because I have explained to you the theory of Buckingham Pi-Theorem, as well as step by step. We have 6 steps to perform the Buckingham Pi-Theorem, right? Please remember this step, otherwise it will be hard for you during the exam. Okay, so you need to show this step by step. Okay, this is example. I will let you to try this example. This is quite pretty easy example. Okay, and for tomorrow we're going to cover the similitude study. Okay, that is actually directly related to this Buckingham Pi-Theorem. Okay, so I really hope that you study and understand well the Buckingham Pi-Theorem before we go for similitude. Okay, so far I think that's all for today's class. This is the QR code for those unable to scan. Please do scan before we end the session today. You have any questions so far? Any issues? Because your test, your test 1 marking scheme, it takes time because we have a lot of students. So in the meantime, we try our hard to finish the marking. Okay, so I think that's all for today. Thank you for your time. Okay, I end my session with Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Thank you.
Wa alaikum salam, doctor. Thank you.
Okay, welcome.